Dear students, our first lecture about Fourir series. In our first lecture, we developed a conceptual basis of Fourier series. Where from does this arise? We looked at the problem from a physics point of view, and we talked about waves, how two waves can produce a complex wave, a non-sinusoidal wave. Like for example, suppose that was this wave, something like this. We found that this wave could be generated by using two sinusoidal waves. If we call this psi t a function of t or function of x, we will sometimes talk about function of t, sometimes we will use function of x. It must be easy for you to switch from one function to another function, because we discussed that at length in our first lecture, so it won't be difficult for you. So if I write this psi t, I'm using time because we're more familiar with time than with this space. Now psi t is equal to psi t, that is this function is composed of two functions, a sine omega t plus a sine 2 omega t. One was having frequency omega, the other was having a double frequency, double that of omega. Or if I like, I can write it in terms of x as variable. I can then write it a sine, in place of omega k x, then a sine 2kx. Okay, and it is not must that the two waves will have same amplitude. Amplitude of this wave and amplitude of this wave, both I have taken as same. This is not a must. Second thing that has to be noticed, that is, this expression is for this particular wave. For a wave that is more complex than this, we can have more these components in that wave. We can have a component at frequency omega, another at 2 omega, another at 3 omega, and so on. So in general, we can say that a general periodic function can be represented by this expression, a sine omega t plus a sine 2 omega t plus a sine 3 omega t plus dash dash, or a sine n omega t. The problem with this expression is that we have used same value of amplitude for these different harmonics, which is not a must. It can be different, so I can write a1 for this, a2 for this, a3 for this, an for this. One more thing that has to be now accommodated, that is, all these frequency components, this all, they have the same initial phase. Everyone has each of them has a zero phase. That means each of them starts from this zero. That is not a must. A particular this component could have an initial phase. It could have started from, say, like this. We say that this frequency, this wave and this wave have a phase difference. This we can accommodate that phase difference here. Till now, all of them have been shown to have a zero phase angle. Now we can accommodate the phase angle. For example, if we take this sine omega t, instead of this we can write sine omega t plus phi, where phi is the phase angle. Now if we do this thing, we have an alternative option for this. Instead of writing sine omega t plus phi, we can write, sine omega t plus phi is equal to sine omega t cos phi plus cos omega t sin phi. Now this that means this single term can be split into two terms, this and this. Now looking at these two terms, we find that phi being a constant, that means if there is a wave like this, its initial phase is what its initial phase was. It any time at any point you can ask what was its initial phase, and that will be the same. So initial phase remains, that it remains with the wave, its value is constant. So if we substitute in place of cos phi a constant, say b sine omega t plus a, here a is cos omega t. It has been a tradition to associate a with cos and b with sine. That is what I have done here. And this a and b, these not only accommodate this cos phi, sine phi, they also accommodate this a1 or a2, whatever these amplitudes are there. They accommodate all of that. And then we have for each term here we have two terms, a sine term and a cos term. This is to accommodate phase. If we take only single term, then phase will not be accommodated. We have accommodated phase, but in terms of using two sinusoidal terms. With this thing, we go to another page and write here psi t is equal to we can write it for every term. We will use two terms for every term. So first term is this. So I will write this a1 cos. I will write first cos term, this cos term. We can check it. This cos term I am writing first. It is a convention. We write cos terms first with this a question. So I write this cos term here first, then sine term, cos term a1, cos omega t, then a2, cos 2 omega t, then similarly a3, cos 3 omega t, then and so on till I have an cos omega n t plus now sine terms. These sine terms, with each term is a sine term. This b sine. So I have b1 sine omega t plus b2 sine 2 omega t plus b3 sine 3 omega t, then plus dot plus bn sine omega n t. Now one more thing, that is this series is complete, almost complete, but with one deficiency. That is, we need to accommodate a term here, that is psi t is equal to AO, this constant term AO, here AO plus A naught or AO, A1 cos omega t plus this cos series, cos omega n t plus B1 sine omega t plus sine then B1 sorry, I should have written here an cos omega n t, bn sine omega n t. After having done this, we have to do one more thing, that is we have accommodated this AO here. Why? We will take it. I will take 2 minutes to come back to this, and I will tell you why I have written it here. Before that, let me put this series in a compact form. I can write psi t is equal to AO plus now cos terms an cos omega n t plus then sine terms bn sine omega n t, n equal to 1 to infinity, n equal to 1 to n equal to 1 to n equal to 1 to n. So we have this as our series. Now having said this, we can yes so this n can go to infinity, and so is the case with this, both of them infinity. This is series, and it can have infinite terms in general. Now these coefficients a naught, a n, b n, these are called Fourier coefficients, and these Fourier coefficients have to be evaluated. We will evaluate them, but before that, let us accommodate infinite terms here. Now we now have this as our Fourier series. Now what is AO? What is this AO? This AO is, it turns out that this AO is simple average value of this. Some functions, there may be a function that has a non-zero average value. There may be functions that have zero average value. Both are possible. For example, if we take sine omega t, and we take its average. How do we take average? Let us see. Let us have a look at that. Suppose we have this sine. So if we take this average, now this is the sine, this is time. We can in place of time we can show the angle here. There is one thing that I need to tell you, is that omega t is an angle. Omega t certainly is an angle. And similarly sine kx is certainly an angle. But for sine or cos or trigonometric functions in general, for them it is not a must that they should be defined for angles. For example, suppose we have this sine x, Taylor's expansion of sine x. We have, if I remember it correctly, it is x minus x cube by 3 factorial plus x5 by 5 factorial plus dot something like that. Now you can see yourself, this x can be any variable. It does not need to be an angle. So sine and cos or trigonometric functions are not necessarily defined for angles. Actually, they started with angles. Then, in real analysis, this was extended to non-angle quantities. However, in these two types of this sine, this wave, in this wave equation, we have this in case of these waves, we have sine and cos, and their argument is an angle. This omega t is an angle. Similarly, sine kx is an angle. So this means that you can express this this Fourier series. Let's write first Fourier series that we have till now. We have it like this: ft is equal to ao plus n is equal to 1 to infinity an cos omega n t. Now then n is equal to 1 to infinity bn sine omega n t. We can have a single variable. Say suppose we have fx. We can express it as simply as this: ao n equal to 1 to infinity an cos nx. This is our variable, and this x is our variable, and this bn sine. This is perfectly correct. No need to put in those factors, but it makes our job easy if we give a physical meaning to those things. And in physical meaning, if we accommodate that physical meaning, we can have this as our omega and k as those constants. that convert time and space into angles. Now with this thing, let us first go to see what is the average value of this sine theta or cos theta. Sine theta or cos theta. Now with this average value of sine theta and cos theta, we were talking about this, and we have this, for example, sine theta on this side, sine omega t on this side. That is what is theta. That is what is theta. You can take theta here, theta sine theta, no problem. The average value of this, how do you find it? Average value, since normally what we call average is sum of all the values divided by their number. Now here you have infinite values. How to calculate their sum? We adopt a strategy. What is that? We divide this angle from this to this into infinitesimal small angular these segments. Say I have theta 1. Say I take this small element, theta 1, d theta, sorry, d theta. This is a small angle at this d theta here, and corresponding to this we take value of sine theta. Let it be this. We take a value of sine theta from some point in the interval, say from the midpoint. At the midpoint, value of sine theta is sine theta. It is sine theta in general. For example, had this been say d theta 1, sine theta could be written as sine theta 1. I have written it as d theta, and so sine theta will be sine theta. Simple. So simple. Now next we have this value of sine theta here at one point is sine theta. But from this point, from the start of the interval to the end of the interval, there are many points. At each point, the value of sine theta is sine theta. We take the value of sine theta constant in this interval. In d theta interval, we take the value of sine theta constant. So at every point of d theta, value of sine theta is sine theta. So if I add all those values of sine theta, I will get sine theta plus sine theta, sine theta plus sine theta plus sine theta plus dot dot dot. How many? That depends upon the size of this. That means a number of values. Number of values depends on, is directly proportional to the size of the interval. Okay, and we can write then number of values n is equal to constant of proportionality into size of the interval theta. Say theta. Now here size of the interval is d theta, so k d theta is equal to dn. Small number of values from this to this can be taken as dn. So I can write it here. How many values do I have? I have dn values in this small interval, dn values, and those dn values, with those dn values, the sum of all the sine theta values in this interval will be dn into sine theta. If there had been only one value, sum would have been sine theta. If 2 sine theta. If 3 sine theta. If dn values from this is dn theta, but dn can also be written as k d theta sine theta. So this is, I will keep it written here, dn is equal to k d theta, or n is equal to k theta. Okay, now suppose now I now have this is the sum of sine theta values from this point to this point. That means in this small interval d theta, what will be total sum of sine theta in the complete this interval here? How much is the complete interval? Is 360 degree or 2 pi radians. So this 2 pi in 2 pi this cycle in 2 pi interval, I will have so many d thetas. Total sum of the values will be simply integral of these d thetas, k d theta sine theta. sum of these k these. So in from 0 to 2 pi, from 0 to 2 pi, from 0 to 2 pi. Okay, now this is the sum of the values of sine theta from 0 to 2 pi. Now what about the number? Divide this by number to get the average. To get the average value of sine theta, this is sine theta. To get its average, I will have to divide this sum by the number. But number I don't know. K d theta sine theta number that is proportional to, number is proportional to, directly proportional to theta. But theta from this to this is 2 pi. So number is k 2 pi, k into 2 pi. I have used this formula, n is equal to k theta, substituting pi, theta equal to pi 2 pi, and I have this. Since this k is constant or proportional, it can be taken out, and we are left with 0 to 2 pi sine theta d theta divided by 2 pi. So this is the average value. We must have a look at this average value. How did we calculate it? This you can see it. Average value of sine theta. How did we calculate it? Let us see. We calculate it by 0 to 2 pi sine theta d theta divided by 2 pi. Now how do we view it? We view it like this. We take sine theta as one value of sine theta multiplied by d theta, that gives us a sum of a few values of sine theta in a small segment of this, graph. This is a small sum of sine theta, and then we integrate that small sum from 0 to 2 pi to get the full sum, and divide that by the number of the these values. That depends upon the interval, that is 2 pi. This is how we calculate average. Similarly, suppose you have to calculate average of, say, ft over full cycle. How would you calculate it? From 0 to full cycle. Say it is full cycle is t, time period t. So you will have ft, one value of this ft into dt. That gives ft dt divided by t, this size of the interval. This is how we do it. Now, this is how we do it. Then we go back and see. We can now find some these average values, which are very useful for us. One is average value of sine theta d theta 0 to 2 pi divided by this 2 pi. This will be 0, straightway 0. Why it will be 0? Because simple. It will be 0 because you can check. You can have a check. There are two ways you can understand why it should be 0. One is a simple intuitive way, and you have, in that way you can think of why its average value is 0, because it has so many values, but they are positive. Half of them are positive, half of them are negative. When you sum them up, you get a sum of 0. So average value of this over full cycle is 0. Excuse me. Average value of this over full cycle is 0. So that is this simple intuitive way of finding this average value. Another way is to integrate it exactly, and it is not difficult to integrate it. It is 0 to 2 pi. Integration of this is minus cos theta, and divide by this 1 by 2 pi. Put it out, this 1 by 2 pi, 0 to 2 pi. That is 1 by 2 pi minus cos 2 pi minus cos 0. That is minus 1 by 2 pi into cos 2 pi is 1, cos 0 is 1, that is 0, that is 0, that's all. Now similarly, if you check this average value of cos theta, over full cycle will be 0 to 2 pi will be that 2 will be 0. to 0, because there will be as many positive these values as negative values. You can have it here. Suppose it goes like this to this to this. Full cycle is from this to this 2 pi. So average value will be 0. So now, but if instead of this, suppose you have average, you want average value of sine square theta d theta sine square theta d theta divided by 2 pi. Average value of sine square theta over full cycle, that will be 1 by 2. That's 1 by 2. You can have a rough this explanation of this. If you think of this like this, suppose this you have sine theta and you now square it. When you square sine theta, it is 1, this is minus 1. Of course, so by squaring it will remain 1. By squaring this will remain plus 1. It will now be plus 1. This minus 1 will become plus 1. Suppose you have this like this minus this plus 1, this minus 1. Now this will be 1 will remain 1, minus 1 will become plus 1. Now no value of sine square theta will be negative because of the squaring. So graph of sine square theta will be something like this. Something like this. So if this is sine square theta. Now you can see its peak value is 1, its minimum value is 0. When you take average, 0 plus 1 divided by 2, 0 plus 1 divided by 2, you get 1 by 2. 1 by 2. You can actually integrate it and get the same value as I told you. So with this we will be using these. That's why I am showing this to you, because we will be using them. Now let's go once again back to our this Fourier this theorem, Fourier series. Sorry. Now we have where we were here. We had ft is equal to a naught plus n equal to 1 to infinity a n cos omega n t plus bn sin omega nt. Not subscript. I'm sorry, it's not subscript here. It is sin omega into nt, or you could have written it as omega nt. Okay, n equal to 1 to infinity. Now we have now if we write it in terms of x, you can easily write it now in terms of x. Those things are now quite easy now. I suppose they will be completely easy now for you. Now what I have to do now, I have to find a naught, a n, a b n. Yes, see how to find a naught. A naught, as you will see that I will simply find average value of ft, and that will average value is denoted by this bar, average value of ft, and you will find that will be AO. Now this will be AO. How? Let me find average value of ft. So average value of ft is equal to integral ft dt 0 to 2. Now what is the question is, what is the period of this? Since we are talking in terms of time, not angle, we are talking, or we could yes, there's one thing. We can take omega t combination as a whole and then talk about theta. That is also an option. Or you can take t and talk about this. It's one and the same thing. That is up to you, which way you like. In both cases, you will find the same value. Let's, for example, it is easier to use omega t instead of t. So if I use omega t is an angle, then I will have to use here 0, this lower limit, upper limit 2 pi, because it is angle. Now, then we will have this not dt, it will be d omega t. Our variable is omega t, not that, divided by 2 pi. Otherwise, if you keep it in terms of this t, if the variable is to be t, then you will have to divide it by t, time period t. These things, I think, should not create any confusion in you. Now, when we do this, see, we first of all, what we do, we substitute this a naught here, a naught d omega t. Since a naught is constant, see what will I will get. Just a minute. If I substitute just one part, only one part a naught here in place of this a naught, rest of keep it there. It will create a or better, if that confuses you, it is better to substitute 1 by 2 pi, 1 by 2 pi, integral 0 to 2 pi, okay, integral 0 to 2 pi, then these a naught plus sigma an cos omega n t plus bn cos sine omega n t, omega n t, omega n t, okay. Now d omega t, that is, now let us go to this 1 by 2 pi 0 to 2 pi, 0 to 2 pi a naught d omega t. A naught is constant, it will come out d omega t, 0 to 2 pi, 0 to 2 pi. Now 0 to 2 pi. Now you have another thing, that is 0 to 2 pi, okay. Then you have one more thing, that is integral. You can take it here, integral an. I have taken integral inside this summation sign, an cos omega n t dt, d omega t, okay, plus similarly bn cos sine omega n t d omega t. With this thing, now this 1 by 2 is common to all of them. Now see, this is an is constant, you can take it out because it is angle theta which is variable here. So cos omega t integral of this divided by 2 pi, it is 0 to 2 pi, this 2 is 0 to 2 pi. You have just seen that you have cos omega n t, this divided by this 2 pi here. This 2 pi is numerator of this, denominator of this. So this divided by this, that will be 0. This, because this is average value of this, is 0, average value of sine is 0. So both of these will vanish and we will be left with just this 1 by 2 pi a naught, and then d omega t, that is that's d theta. This is d theta. Integral of d theta is theta, that is theta, integral of d theta, and we have 0 to 2 pi, the limits, that is 1 by 2 pi a naught into 2 pi minus 0, that's 2 pi. 2 pi cancel, you get a naught. So what is then, what a naught turned out to be? A naught turned out, now go back and see what we started with. We start with this and then this is average value of ft. So a naught is average value of ft, average, and that average value is this, 1 by 2 pi 0 to 2 pi ft or f omega t d omega t. That's one. Now remains an. Again, ft is equal to a0 plus sigma plus sigma. It is an bn, an cos omega n t cos omega n t, and bn sine omega n t. You know that these limits, these value of index, that is 1 to infinity, 1 to infinity, 1 to infinity. Now we want now an. For extracting an from this, you multiply throughout by cos omega nt. When you do that, you get cos omega nt. You will see why we did it. Cos omega nt ft, and then a naught cos omega nt, cos omega nt, plus then this plus sigma n cos omega nt, cos omega nt, okay, that is same, into this cos omega nt that you are multiplying with. This becomes cos square omega nt plus, then you have bn sin omega nt, sin omega nt, cos omega nt, cos omega nt. Now take average value of this, all of them, that is 0 to 2 pi, 1 by 2 pi. You have to multiply 1 by 2 pi into 0 to 2 pi, d omega t, 1 by 2 pi, 0 to 2 pi, 1 by 2 pi, d omega t, d omega t, 1 by 2 pi, 1 by 2 pi, then it is 0 to 2 pi, then you have 1 by 2 pi, 0 to 2 pi. Then see what will happen. This will vanish. This is simply average value of cos omega nt, 0. Average value of sine omega, sine into cos, they can be combined into 1, that is the sine or cos. This average value of this is also 0. Only average value of this remains, that is 1 by 2. This 1 by 2, and when we take that, we have 1 by 2 pi, 0 to 2 pi, cos omega n t ft, d omega t is equal to, that is equal to now this vanishes, this lost also vanishes, only the square term remains there. You can check it by actual calculation, you can check it, or you can check it like this. If you have cos into sine, so you have suppose 2 sine theta cos theta, just multiply it by 2 sine theta cos theta, and then that is equal to sine 2 theta, sine 2 theta. So this is simply sine 2 this, and again that will vanish. Now you have cos that is equal, this is equal to 1 by 2 pi, 1 by 2 pi into an, and cos that, and rest, sorry, 1 by 2 pi divided by this cos, that is equal to 1 by 2 average, that is average value of cos square, that is 1 by 2. So what we get this 2 and 2 will cancel, we got an. So an is equal to an. Finally an turned out to be this, an is equal to 1 by pi, half of time period, 1 by pi integral 1 by 2 pi integral 0 to 2 pi, okay, then 0 to 2 pi cos omega nt, cos omega nt d omega t. This is for an. Similarly, we can find 1 by pi, 0 to 2 pi sine omega n t d omega t. Thus we have the coefficients of Fourier expansion. We will continue with this in our third lecture.